Hey everybody, and welcome to section 9.2, which concerns outcomes and type 1 and type 2 errors. All right, so let's begin. So when we perform a hypothesis test, there are 4 different outcomes depending on whether the null hypothesis is true or not, and the decision to reject or fail to reject the null hypothesis. Okay, so this is a really cool little table that is actually in your textbook, so I stole it. Here are the 2 possibilities for the null hypothesis. Either it's true or it's false. Okay, there's no halfways. It's either true or false. Your null is either true or false. Okay, so these are the 2 possibilities. Now, the actions we can take, we can either reject it or fail to reject the null hypothesis. Okay, so remember the null hypothesis is like something, it could be anything from, the average time spent waiting at the DMV is 2 hours, mu equals 2, either that's true or false. That depends on actually where, but, or it could be like the proportion of statistics students who are also taking calculus is equal to 25%, something like that. Okay, so you have this statement, okay? Now either it's a true statement or it's a false statement. We don't necessarily know. That's why we're going through this testing. And based on this, based on the calculations that we're going to get into, so we haven't actually gotten into those yet, but just I'm telling you from like a theoretical level, either we are going to reject it or we're not going to. Now, if the null hypothesis is true and we fail to reject it, that's correct, right? We don't want to reject the truth, okay? If it's true and we reject it, that's actually called a type 1 error, okay? Where you actually reject the truth, okay? Now, if the null is actually false and we fail to reject it, that means kind of like you're believing a lie, right? You say, well, it looks like the null hypothesis is true, but it's not. It's false. That's called a type 2 error. And if it's false and we reject it, that's the correct outcome. Okay, so these are the 2 situations we want to occur, but this type 1 and type 2 error, there's a possibility of that happening, okay? There's always a possibility. And it's actually, we can actually measure it. We can give a number to it. All right, so let's talk about the 4 decisions again. So this is the same thing I said, but in a different way. So if you decide not to reject the null when it's true, that's correct. Okay, when you decide to reject it when it's true, that's incorrect, right? And that's known as a type 1. The decision to fail to reject when it's false, that's an incorrect, a type 2 error. And when you reject the null hypothesis when it's actually false, that's correct. And the probability for this happening, the number 4, is called the power of the test. So we definitely want the power of the test to be as close to 1 as possible. Okay, so here's another way of thinking about it. Type 1 is when you reject the truth, right? So in other words, reject the null when it's true. So type 1, I kind of like remember the difference as this is rejecting the truth. Type 2 would be kind of like believing the lie, right? Where we fail to reject the null hypothesis even though the null hypothesis is false. So you can kind of start seeing that type 1 and type 2 errors can be really serious, okay? Especially if you're talking about medications, types of treatments. In the field of medicine, there's so many studies going on about different types of medications. Do they work? Do they not work? So you definitely don't want a type 1 or type 2 error to occur in that situation. So, and just like I was saying before, each of those errors occur with a specific probability. It's and they have names. Like we've labeled them, right? We've labeled them using these letters alpha and beta. Okay, so the letter alpha, which is it represents the probability of a type 1 error, right? In other words, what's the probability of rejecting the null hypothesis when the null hypothesis is true? So rejecting the truth or denying the truth, right? That's the type 1. So beta represents the probability of a type 2 error. Okay, so in other words, the probability of not rejecting the null when the null is false. Okay, and then the power of the test is actually the complement of beta. So the power of the test, remember, it's a correct probability, right? 1 minus beta. It's represented by 1 minus beta, okay? Because it's the probability of rejecting the null hypothesis when the null hypothesis actually is false. And this is actually what we want. We want a high power that's close to 1 as possible. One of the things we can do to increase the power of the test is increase the sample size. So where would we be without super fun examples? I do not know. Okay, so let's suppose the null hypothesis, HO, is Frank's rock climbing equipment is safe. So in this situation, can you figure out what the two types of error could be? So just if you want to write them down, you can pause it and then go over the answers with me. And if you just want to go through it, let's just go through it. Okay, so a type 1 error could be that Frank thinks his rock climbing equipment may not be safe when in fact it really is safe. Okay, so it's true, but he thinks it's not true, right? It's the null hypothesis is true, but he is rejecting the truth, right? He thinks that his rock climbing equipment is not safe when in fact it is. Okay, so then that would be alpha. Alpha would be the probability that Frank thinks his rock climbing equipment may not be safe when in fact it really is safe. All right, so type 2 error in this case would be that Frank thinks his rock climbing equipment is safe when in fact it's really not safe, right? He's believing the lie, right? So it turns out that in type 2 error, null hypothesis is actually false, right? It's not safe, but Frank thinks it is safe, right? So and then beta is the probability of this occurring. Now, which one do you think is more dangerous or has greater consequence? If you said type 2, of course, right? How crazy. You're going to go and think it's safe. You're going to happily climb your rock climbing equipment and it's going to fall apart on you. And oh my gosh, that's a really bad thing. So in this case, the type 2 error was of greater consequence. All right, so let's do yet another fun example. So suppose that the null hypothesis is that the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. Okay, so what would be the type 1 and type 2 errors? Okay, so the type 1 error would be the emergency crew thinks the victim is dead when in fact he really is alive. Okay, so that would be the probability that the emergency crew thinks the victim is dead when in fact it really is alive. I mean, and that's pretty scary, right? I mean, if they think the victim is dead and they like package this person up and send them to the morgue and they're like alive, that's so scary. Okay, and the type 2 error is the emergency crew does not know if the victim is alive when in fact the victim is dead. Okay, so that's also a possibility, right? They think maybe, we're not sure if he's alive or not, but in fact it's actually dead. Okay, so so what would be the greater error? I would think that the type 1 error would be worse because you definitely don't want to treat an alive person like they were dead. Okay, so let's do another example. Yay. Okay, so It's a Boy's genetic lab claim to be able to increase the likelihood that a pregnancy will result in a boy being born. Statisticians want to test this claim. Suppose that the null hypothesis is It's a Boy genetic labs has no effect on gender outcome. Okay, so what would be my type 1 error and what would be my type 2 error? So, take a second, think about it, pause the video if you need to, write it down. It's fine. I'll be here. Just kidding. I mean, in video form. Okay. Type 1 error. So remember, we reject the truth. So type 1 error is when a true null hypothesis is rejected. So in this scenario, we would say, okay, we think that the lab influences the gender outcome when in fact it has no effect. Okay. So remember, type 1 is denoted by the Greek letter alpha. Okay. Then type 2 would be when we fail to reject a false null hypothesis. We're believing a lie. In context, basically, we're saying, oh, we think it doesn't influence the gender outcome of a pregnancy when in fact it does. Okay, so we believe the null, right? The null hypothesis was that it has no effect. Okay, so we believe that, but it's actually false. Okay, all right. And the probability is denoted by beta. Okay, so now which one would be greater consequence? I mean, obviously the type 1 error would be, right? Because people would be trying to have babies thinking, oh yes, I can have a boy or I can have a girl or whatever it is. I guess this weird one is just, it's a boy, but they're spending money that's basically going to waste for something that does not work. Okay, and then so now you can see how important it is to make sure that you're carefully screening things, because you do not want to waste your time and energy on something that's not going to help you. Okay, OMG, so many examples, but this is the last one. So a certain experimental drug claims a cure rate of at least 75% for males with prostate cancer. Let's describe the both type 1 and type 2 errors in context, and which error is more serious. So if you think you can do this, I'm sure you can. Go ahead and pause the video and try this out for yourself. Okay, so I'm assuming you paused it. Good for you. So let's see if you can, if you did type 1 correctly. So type 1 would be that the cancer patient believes the cure rate for the drug is less than 75% when it actually is at least 75%. So we're rejecting the truth. So in this case, at least means equal to or greater than, yeah? So this is rejecting that truth and thinking that it's less than 75. Okay, so when in fact it is at least. So type 2 error would be the cancer patient believes the experimental drug has at least a 75% cure rate when it actually has a cure rate that is less than 75. So which one of these do you think is the more serious? Now, in this case, type 2 error is more serious, right? Because the patient thinks the drug works at least 75% of the time. They probably would use that drug, right? And in fact, it doesn't, and I am thinking of a particular drug that everybody said was super helpful in fighting coronavirus, but it ended up not being that way. So I'm sure you can think about it and see how important this kind of situation would be. It could cost lives, right? Okay, so that's section 9.2. Your practice is 11 through 20. Okay, so I will see you guys on the next video.